My wife and I have been sharing an M1 iMac as our home desktop for 4.5 years now, since it came out. And honestly, it's been fine, but decreasingly so over time. Now, you might think it's the hardware, but it's not. The machine still feels quick, especially since I splurged on upgraded memory when I bought it. No, the problem is the software. Because here's the thing nobody tells you about Apple's family computers. macOS handles multi-user account support about as gracefully as I handle small talk at parties. And I know they know this because it's been this way for 15 years. Everything becomes weirdly sluggish. RAM gets locked up between multiple active user sessions. Permissions, which is like a thing that should have been solved in the 80s, becomes a Byzantine nightmare, even with mother friggin' both of us being admins. And that's to say nothing of the multiple computer lifestyle which we live. Now, Megan doesn't care because 99% of what she does is web-based anyways. But I have a MacBook Air that I primarily use, but I still use this iMac. And having the two constantly out of sync bugs the crap out of me. I've got different apps, different shortcuts, different file structures, bleh. Plus, we need a computer for our upcoming merch fulfillment room. And this 24-inch iMac fits the ticket perfectly. So what am I to do at home? I mean, the studio display is $1,600 and uses a panel that's essentially unchanged since the Obama administration. I mean, the specs were dated when it launched 3 years ago. I had a fairly critical review of it, and people said, why are you saying this? And it's because it wasn't that good then. It's certainly not now. And with rumors of a replacement coming, buying one today feels like purchasing a flip phone in June of 2007. Now, I know what you're thinking. Why not just buy a non-Apple monitor with way better specs for much less money? Number one, single cable plug and play is way better for noobs. Don't tell my wife I called her that. And then two, Apple monitors actually have really great built-in speakers, a rarity. And number three, this is perhaps the most important for a weirdo like me, non-integer scaling on macOS drives me insane. Text at 4K on a 27-inch display is just a little fuzzy. Enough that it me vuelve loco. And I know that I'm pathetic, but I want an Apple monitor, ideally on the cheap. The thing is, I've already got one. It's just inconveniently attached to this worthlessly old and slow 2014 computer. It's 5K, it has good speakers, and it still has a beautiful case. Now, Apple used to solve this old computer but good screen problem elegantly. It was called target display mode, and it could turn any iMac into an external monitor with a simple keyboard shortcut. Sure, the computer gut still had to be in there, but when your all-in-one computer had become too old to compute, well, it could just stand in as a display. It was brilliant. But the 5K iMac killed that feature, and here's why. In 2014, there literally wasn't a video standard that could push 5120 by 2880 at 60 Hz through a single cable. DisplayPort 1.2 maxed out at about 17 gigabits per second, which was barely enough for 4K 60, and 5K at full 10-bit color, well, that needs 21.5 gigabits per second. Now, HDMI 2.0 had just been finalized around this computer's launch, but it also couldn't handle that bandwidth. So Apple did what Apple does. They got weird with it. Working with LG, they built a custom timing controller that split the display into two logical halves. So the GPU was pushing out two DisplayPort 1.2 streams, one for the left side at 2560 by 2880, and one for the right side at the same resolution. And then the controller is what stitched them together seamlessly. It was simultaneously brilliant and ridiculous, like most Apple engineering, and it was all kind of irrelevant because DisplayPort 1.3 arrived literally months later and made this whole Rube Goldberg machine unnecessary. So, when LG shipped their ultra-fine 5K a couple of years later, well, it just used DisplayPort 1.4 over Thunderbolt 3. Clean, simple, standard. But Apple never brought target display mode back to the iMac, not even on its current M-series iMacs where it would be trivial to implement. So, enter the wonderful world of aftermarket Chinese display controller boards, trying to do what the iMac's computer did without the iMac's computer. For years, these controllers were expensive, unreliable, and required a ton of sloppy jerry-rigging. But lately, they've gotten good, like really good, and pretty affordable. So we are going to gut this computer. We're going to keep the display. We're going to add a controller board that speaks modern DisplayPort, and boom, our iMac Frankensteins as an external monitor.
A little longer than a few minutes later.
That was a month ago. I haven't eaten. I haven't shaved. I haven't slept. This video has taken forever, not because this project is complicated, but because it is convoluted and information online is scarce or simply wrong. The best resource is a 127-page Mac rumors thread that is impossible to search. Ain't nobody got time to read all that. Save for me, he who walked through blood and bone so you wouldn't have to. So let me break it down for you. First, you need to disassemble your computer, which is honestly really quite simple. You use a cutting wheel to crack the adhesive that lines the display's perimeter. You then disconnect the two display cables, and then you set the display aside and spend a bunch of time undoing a bunch of screws to rip out all of the components from the Mac that could once run Windows. You got the speaker, the blower fan, the power supply, don't touch the spicy bits. There's a spinning hard drive in there if you were cheap a decade ago and didn't opt for an SSD, and last you've got the motherboard. If you really want to have fun, you can pull the heatsink off of that motherboard to discover that, holy crap, an Intel i7 4790K and a Radeon M290 were once pushing 15 million pixels a decade ago. Be careful not to destroy the screen, the speakers, the case, and optionally the fan, but everything else is going to the recyclers, so pay it no bother. The disassembly is easy, and a number of illustrated and video guides on how to do the procedure can be found for your model, so you ain't gonna hear it from me. But we should talk about models because not all 5K iMacs are made equal. The 2014 was sRGB only, peaked at just shy of 400 nits, and had widespread reports of image retention and ghosting. 2015 fixed the ghosting, brought DisplayPort wide color, but still topped out at under 400 nits, and many of those panels suffered from pink edges and uniformity issues. The real leap came in 2017 with DCI-P3 and a new backlight design pushing 500 nits, which sounds marginal, but brightness is a logarithmic scale, so it's actually a massive 43% jump. And then 2020 just tacked on True Tone. The sweet spot for art purposes? The 2017 and 2019 models. These get within spitting distance of the studio display in quality and frequently go for under $300 on Facebook Marketplace, even cheaper if it's a base config with spinning rust, since, again, we only need the screen and the speakers. Just avoid the 2017 iMac Pro and the 2020 27-inch if you want functioning speakers, because their T2 chip is what handled the audio crossover on die, meaning you'd need to build an external crossover circuit to use the internal speakers, and you ain't doing that. Unless you find a 2020 nanotextured unicorn, just stick with the slightly older models. Of course, I say that with authority, having bought a 2014 and 2020 model respectively. Literally the worst two picks. Now, the effectiveness of this project will live and die by the driver board itself, and unlike the screen, this ain't a one-size-fits-all. These boards come from a handful of Chinese manufacturers, and while Stone Taskin is the established name with reportedly great customer service, clone boards from random AliExpress sellers work just as well for $50 to $80 less. You're just rolling the dice on support if something goes sideways. The current community favorite is the MediaTek-driven SA1 at around $200. It's only been out for about a year, but it's quickly become the default recommendation because it can do it all. It offers single-cable DisplayPort 1.4 and HDMI 2.1 that does full 10-bit 5K for your PC, but you've also got a single-cable USB-C input with 90 watts of power delivery for your Mac. There's a solid audio amplifier for the internal speakers, and it also has an onboard current booster, which allows you to push the display's backlight a little bit past the 500 nits to about 550, putting it darn near the studio display's 600. The downsides? Well, it's relatively new, so there's less long-term data, and it does not come with an IR remote for the on-screen display menu. You're stuck with physical buttons on the board. If you want the tried and true option with years of proven builds, the Realtek-driven R1811 is about $260 and remains solid. Its speaker amplifiers are widely considered the best. It has the most expansive I/O, though just 65 watts of PD. The biggest catch is that it's the most expensive, it runs hotter, and has a rather loud onboard fan, which most people swap for a Noctua at additional cost. Oh, and some of the no-name boards are known to occasionally fry MacBook USB-C ports, so that ain't too great. The last couple of options are the FA1 at a cheaper $160, but it has noticeably lower peak brightness compared to the SA1 or R1811 at around 470 nits. Not a terrible choice if you've got a 2014 panel, otherwise this probably ain't the move. And then the budget option is the AA1 at just $120, but it maxes out at 8-bit color and the HDMI port can only do 5K at 30 Hz. But over DisplayPort or USB-C, it's actually a great option on the cheap if you don't need reference-grade performance. I picked up the SA1 and I purchased the complete package, which comes with 1. The driver board, 2. Replacement display cables for video and power, 3. The OSD control board, 4 crossovers for speakers, 5 a lousy short USB-C cable, and 6 a mid-quality 120-watt power adapter. Yeah. Save yourself $25 by just buying the base kit and the crossovers separately, because the near universal recommendation is to opt for the Meanwell LRS 150, a tried and true 24-volt switching power supply from one of the oldest names in the game. When you're feeding both your display and your Mac, you really don't want to cheap out on PSUs, and just $20 on Amazon can get you this absolute legend. Unless you didn't pay attention when you bought yours, like mine, and you ended up ordering a knockoff. Great. Still seems to work. A few extra components. That was the power supply cracking inside. A few extra supplies and components are as follows. A DC buck converter to step down the 24 volts from my PSU to 12 volts for the fan controller that I have to add to regulate the speed of the blower fan that we're keeping around to cool everything inside. Then, to make things feel extra fancy, I got a DC pigtail to go from my power supply to my driver board, Captain tape to make sure that we don't short out any of the components against our chassis, adhesive wheel weights to balance out that hinge, and a couple of input cables for our display. So, that's all the background info you need. Time to put it all together, except for wait. Now, you could glue or tape components into place, I guess, and believe me, people have. But that is no way to live when companies like today's sponsor, Bamboo Lab, make 3D printers that can help bring a much better install experience. Their new H2S is pretty remarkable. $1,249 gets you a massive 340 by 320 by 340 millimeter print volume. And importantly to this project, an actively heated chamber capable of maintaining 65 Celsius. You see, these components are going to get hot, and most 3D printers that spit out PLA or even PETG plastic will not be able to withstand the temperatures inside of our enclosure. Just by placing PLA over this heat gun for a couple of seconds, you see how easily it warps and deforms. But with ABS or ASA, it's a whole different story. The thing is, ABS and ASA are notoriously difficult to print. They warp on the bed, they shrink when they cool, they struggle to adhere to the build plate, and more. Well, not so with the heated chamber, the AMS HT filament dryer, and carefully calibrated factory profiles. Since it's Halloween, I'm going to print this in orange, obviously, and all I've got to do once I drag my parts in is push print. That's literally it. No custom settings, no special bed prep, nothing. If you told me that I would be able to print high temperature plastic like this even 3 years ago, I wouldn't have believed you. But now it's a reality and wrapped up into an affordable package with Apple-like simplicity. Bamboo Lab's biggest Black Friday sale ever is going on now for printers and materials of all price points, from noobs to professionals. So check it out with the link below. Now, about those 3D files. Here's where things get frustrating. There are literally hundreds of parts designed by dozens of DIYers scattered all over the internet, and they are all horrifically labeled. Some are designed to work for specific boards, some work with multiple, some haven't been updated in years, and some don't even fit. Some don't account for newer hardware. It's a mess. I have linked the specific files that I'm using, which are the ones that you will actually want to use, in the description below, and don't require you to drill new holes or perform blood sacrifices. Like, look at how someone without a 3D printer massacred our boy. Don't do this. But I didn't find everything. So I had to make myself a part with very crude modeling skills. A little adapter that converts my DC to DC step down for my fan to the mounting size originally called for in the model that I found online. Because of course the dimensions didn't quite match. All right, with all the parts printed and ready, let's actually wire this thing up. And spoiler alert, it's way easier than you think. First step is to install the power supply, because the left speaker assembly covers half of our power supply mounting brackets. So we screw our first bracket into the power supply with M3 screws. Luckily, nobody else other than me is going to be opening this thing ever again. Well, frankly, I'm not opening this either, so it doesn't matter. All right, we got the bracket on. Now we have to install the left side support brackets. These just hold the power supply up, because the power supply only has screw holes on one side, but that's okay. No matter, we're just gonna grab those same M3 screws. You can't use the originals because they're too short, but with a couple M3 12s, or probably 10s would be better, we can screw this thing right into place. Ah! And if I did my job right, Perfect, power supply is in. Time for the speaker. Okay, we'll grab this left speaker assembly. We lower it into place. We're gonna put that power cable going to our power button back over the top into its little grommet. And then we simply lay this down. And we are going to want to reuse the original screws on this one, because otherwise we're gonna get some mad vibrations and harsh resonance. No good. Some people will pull out the stock power connector and just fish cables through there. I don't like that idea. I want to keep using the original power connector because it looks nice. And so we need to splice the incoming AC into our power supply. This lead is too short, and this stuff is crazy thin. It's 20 AWG, but because it's only ever carrying like 2 amps, it's fine, doesn't matter. But we're gonna put some butt end connectors and then wire this thing up. So let's do that. I need some wire. I'll be back. And all my good wires at home, so I'm going to decapitate a couple of pairs of alligator clips. All right. Pink is best. Yeah, there we go. Now we're getting some shrinkage. All right, the power supply end is good, but now I need to connect to my actual power connector. This is a really great tool for people who are lazy and or unskilled. I'm both. Basically what it is it's just a ball of solder on the inside that when you heat it up with the heat gun, melts that solder, electrically connects the 2 wires, and then heat shrink holds the wires themselves together. They're really great, they're super cheap, and you don't need any expensive tools like these. Here's the trick. You need to make sure that both wires overlap the solder ball, and then you kind of just push them together like they want to kiss a little bit, and then when we turn on the heat, it'll just kind of meld everything together. So, make sure you can see both ends of each wire on both sides of the connector and apply heat. The heat shrink will start to go before the solder ball does, so don't worry about that too much. There you go. You can start to see the solder flow when it fills the whole cavity up with beautiful silver. And you don't need to melt the whole thing, because then you can damage the insulation on the wire. Ooh, that's beautiful. Okay, this is our DC step down. It's going to take our 24 volts and turn it to 12 so that we can run our blower fan at its proper voltage. These things are pretty reliable when you get one that's reliable, but the thing is you have no idea whether it's going to be good or a piece of crap until you plug it in. Never install one of these without testing it first, because it is just luck of the draw. Half of them come broken, that's why they're a few dollars a piece. These things are pretty cool. So like I mentioned, we're putting 24 volts in, and all we have to do is twist the set screw on this pot that will adjust the output voltage. So since our fan is 12 volts, we just need to bring this display all the way down to 12.0. And now our fan controller will have the perfect voltage it's expecting. Pretty cool. This is what gets hot. Okay, after a night of troubleshooting, I have figured out the hardest part of the build. Hard for me, not for you, because I did all of the legwork. You just get to copy my homework. So listen up, class is in session. Coming out of our DC power supply, we have the positive and negative voltage leads going to the input of our positive and negative terminals on the DC step-down. Wow, even you can follow that. Very simple. Coming out of the DC step-down, we have our positive and negative leads going into our 12-volt fan controller. Now our fan controller has 3 headers. There's the voltage input, there is this, which is attached to this little ring terminal. Kind of looks like a ground, but it's not. It's actually a thermistor that is consistently measuring the temperature inside our monitor. This is fantastic because using the janky Chinese firmware that it took me forever to figure out how to program, and I was only able to do so because I found an Amazon reviewer that left instructions because they were not included in the box, thank goodness. I was able to set up a fan curve so that at 30 degrees Celsius, the fan kicks on at a very low speed and then slowly ramps up or down based on that temperature. This is great because the fan isn't spinning loudly all of the time. Then we have the last header, which outputs to our fan. Now our fan, because of course it's Apple, is not only using a non-standard connector, but also deviates from the standard 4-pin connector output that literally every PC fan on the planet uses. So on a standard PC fan, going from right to left, you have ground, you have voltage, you have your control, and then you've got, if it's a 4-pin fan, PWM for your PWM control. Well, Apple thought, hey, let's be dicks and not do that, because I plugged it in after I terminated the new wires, because also the connector's not the same, and no worky. So I had to take apart my other fan to see if there were maybe markings on it, because nowhere online, anywhere, as best I could tell, is this fan's pinout documented, and I didn't want to poke it with a multimeter for an hour. So I just destroyed this fan and check it out. It is labeled. So if you're looking at the connector, you see the copper side going from left to right, you have PWM, control, ground, and then voltage rather than voltage ground. Wow, thanks Apple. So yeah, I spliced all these connectors. I attached them to an old 4-pin header that I had on an old PC fan, because this is clearly a PC fan header, except for, oh wait, no it's not. So even this doesn't really quite sit flush, but it's enough to get an electrical connection, and I don't care anymore. So there you go, how to set up the fan circuit. This is the hardest part, it really is. Behold, a printed part in black that will serve as the only visual anomaly that, wait a minute, that iMac is not a standard iMac. Yeah, this is our input and control board, and it's going to replace the RAM door. 4 buttons will allow us to navigate the on-screen display, and then one of our 2 inputs will be located here, DisplayPort. Unfortunately, due to bandwidth limitations, our USB-C has to be routed elsewhere, but maybe someday it could be located here. So I made a hole for if and when that day arrives, but I don't want a hole at the back of my iMac, so I also 3D printed a TPU plug, which is basically rubber, a very difficult material for many printers to print, but not the H2S. It handled it in total space. This part is undergoing a lot of stress because of all the cable weight, and you don't want to screw into plastic if you can avoid it, and so I'm using these brass inserts. You heat these puppies up, it melts the plastic surrounding them, and then when the plastic cools down, it grabs on really tight, and you can screw directly into it as if it were a machined part. It's awesome. Let's do it. And hey, nice. Now, this might look like a problem, but it's not. This is our power button, and I don't want to use the power button on here. I want to use the beautiful aluminum power button that's already on our iMac. So we're going to lob this off the board and splice our wire so that we can connect it to the original. Since our power button does not exist, goodbye. We no longer need the cable. Well, actually, we do need the cable, just not here. So we're going to twist these together, and while you could just wire nut them or Wago them, or frankly, probably just electrical tape and leave it, I'm a completionist, so I'm going to solder it real quick. So this is our ground. We need our ground too because, well, you need the ground to be able to make the button do the button. So we need to splice this because it still needs to go to this board, but we also need to steel it. So we're going to come down a little bit to get away, give us some room. And now we're going to go chip, chop, chip. What I lack in soldering talent, I make up for in chutzpah and charm. Luckily, this is just for a power switch, not like any reasonable amount of current. Otherwise, I would be a little more careful with my soldering. But you know what they say, life is too short to be thorough. And so now, all we need to do is put the parts together and screw. Land ho! That actually looks even better than I thought it would. The print is perfect. Like, look how nicely it matches the radius of the case. Wow. So this printed board is going to hold our DC step down and our 2 crossovers. The crossovers on the right use the yellow and green cables, and the left use red and black. The thing is all of these were wired backwards. So I will link in the description below a very helpful forum post that helps you correct this if, in the event, like mine, yours are wired backwards. All right, so we'll pull all of the wires up, and then we screw this thing into place. Oh, that looks sick. And you might want to screw in your driver board first, because it's going to get tight after we screw this plate down. Big mess of wires. I'm going to retire before this thing's in. Okay, once you've spent an unreasonable amount of time routing cables such that your components here don't smash any of said cables, pull this thing back out because you're dumb and you forgot to put in some counterweights. You see, the Mac was pretty heavy. You had a big copper heatsink, you had the CPU, you had a GPU, and we're putting in some very, very light stuff. So we've actually shedded off 650 grams of weight that we need to replace because it's sprung precisely for the distributed weight. So we've got to put 650 grams below the hinge, otherwise we're in for a bad time. Which means weights. I'm using automotive weights. They're 1 ounce each, and 650 grams, you're like, oh, that's not too many. No, it's 1, 2, 3, 4, 5, 6 strips of 4, that's, what is that, math, 24? 4, 8, 12, 16, 20, 24. I'm a YouTuber, not a mathematician. 24 of these weights that I have to fit around here somewhere without touching any of the other components. I can fit 1 or 2 here, definitely 1 up here, definitely some here. Anyway, put your weights in and make sure you don't put them beneath where something electrically conductive is going to sit on top. I'm doing good, guys. That was yesterday. Today, I am not doing good because I fell down the stairs and laterally fractured rib number 10 on my left side. It hurts to stand and talk and breathe. Please buy a Bamboo Lab printer so they can pay for my medical imaging. Okay, so where did we leave it yesterday? We've got all our ballast in. We need to finish putting this board in, our final driver board, and then we connect the cables to it and the fan to the fan assembly and our fan controller, and that's pretty much it. We're in the home stretch. We need to put the thermistor wire for our fan controller somewhere where I presume it'll be a little toastier. And I think over here by the crossover boards and by the power supply is going to be our best bet. The power supply should be the single hottest component inside the case other than the display itself, and this is pretty close to all of them. I also designed a little 3D printed standoff board for my fan controller, but then I accidentally broke them off because I didn't have the right screws, and then I was going to redesign it, but I broke my rib, so I don't really care anymore. I'm going to hot glue this into the case. Captain tape is really nice because it has a super high melting temperature and it looks yellow. Look at that. May as well be welded into the case. You would be shocked at how many things professional, like real legitimate professionally sold accessories are just hot glued into stuff. Hot glue is the one thing that fixes all. Okay, everything is pretty well buttoned up except for the stuff that needs to plug into the board itself. Everything else has got Captain tape on it. I've got a really long audio cable because it was too short and then I made it too long. And I've got a long power DC cable for the board as well as my DisplayPort cable. But I'm just gonna plug these in before I try to screw the board down, especially given that this adapter sits on top of the audio connector. And then I should be in the end game here. So there's the audio. This is my I/O, which I believe goes over here, correct? Power LED is, yes, it sure does. So we're gonna put this here. Now that those two are in place, we can put the rest down. Okay. That's long enough, yes it is, good. Okay. Okay, we're almost done and it looks fantastic, but there is one weird thing we have to talk about, USB-C. You know that panel-ready DisplayPort connector that we installed at the back, the one that looks fantastic? Well, you can find panel-ready mounts for DisplayPort, for HDMI, but USB 4, not really, it's still too new. So I had to either choose, do I want to sacrifice power delivery or do I want to not run the monitor at 5K? Neither are ideal. I was able to find one cable from the UK that I had to import and then another brand new one, I guess, that was here in the US, but they both required shipping. They were both quite expensive and I think a USB cable is just going to be the better move. But where do we route this through? Well, the Ethernet port. But how are we going to add a pressure relief system so that we don't just rip it out of the computer? This, a very clever 3D print that's all friction based. Let me show you. And so we're going to push our cable straight through and check it out. Just like that. We have a pass through, but you're thinking, well, hold on, that's still not tight. And well, you would be correct. How are we going to do that? Well, with this very cleverly designed wedge that will allow us to just wedge the connector in between the case and the plastic part itself. Oh, that's sick. Doesn't push in, doesn't pull out. That's awesome. And then pull your board off a third time to attach the display connector and also the backlight connector. Okay, now we can finally button this thing up. And now we reapply the display adhesive. And if the adhesive you buy on Amazon is slightly different than the model you actually have, well, not to worry. They're all pretty close and we're not as worried about airflow as you would be on the original iMac, so YOLO if your antenna lines are a little bit off. Okay, so I've got my backlight cable in. I'm putting in my display cable. There's not really any comfortable way to get this done. Just got to be careful because this thing is pretty fragile. And then I recommend you get a friend to pull off the adhesive and lower it into place, because really, you've got one shot. And if you botch it, that's it. You got to redo all your adhesive over again. So I like to start off with the adhesive basically to the point where you can get the bottom stuck, and then you'll finish the rest of it once it's in place. Okay, you ready? Moment of truth. Let's make sure that this cable's routed. Out of the way. Okay. Yep. Get your corner there. All the way in the corner? Mm-hmm. Okay. And we'll just pull these tabs off here. Pull these tabs off, pull this tab off, pull this tab off, pull this tab off. You got it? Yep. Okay. No looking back now. And apply pressure to get seal. Hey. Hey, it's closed. I guess we didn't test to see that it works before we closed it. That's a real test of faith. I just needed to turn it on. Oh, I cried this morning. It hurt so bad, and I was about ready to cry again. Oh, I can't laugh. Good. It's on. It looks good, too. It looks really good. I am so pleased with the way this thing turned out. And while it takes a few seconds longer to connect to my Mac than my studio display does, that's quite literally the only difference that I can see between these two monitors unless I'm really nitpicking. They both get shockingly bright, their panel uniformity and contrast ratio is very similar, they're obviously both the same resolution and thus equally sharp, and actually, I kinda dig the chunky bezels and the chin of the old iMac because it places the display 1.5 inches higher off the desk, which, given the default tilt stand on the studio display is too short for almost literally everyone, this is nice. Really, my only complaints are the lack of a webcam and the fact that the speakers just don't have equal performance to the original Mac I started from. And even those old iMac speakers, while good for their era, pale in comparison to the studio displays of today. But having said that, the scoreboard. I mean, I built this entire thing for less than a third of the studio display's cost. The $50 Logitech C920 murders the studio display's webcam, and you can get some literal pro-level reference-grade speakers that would still come in under budget and absolutely spank anything you've probably ever heard, period, like in your life, out of any speaker ever. Or just get some cheap desktop speakers for $100. By installing Better Display and EQ Mac, you can natively control brightness and volume as if it were a legitimate Apple display. And I mean, that and construction quality are really the only reasons that the studio display is even compelling to begin with. This does all of that for less money, a lot less money. And while there are excellent OLED and mini LED panels available for less than the studio display, you would be hard pressed to find a better screen than this for under $500. It was a fun project, relatively easy, and has provided me with a monitor that will honestly last me for years to come. Thanks so much for watching, and as always, stay snazzy.